You should be able to see my screen now. Welcome to the end of the work cycle update for stakeholders. I am not Chrissy Rismeyer, who is usually the person who does this part. She is out sick today, so we are gonna just wing it without her. And you'll have to accept me as a pale substitution. These updates were created in response to stakeholder feedback that it would be helpful to hold a regular update meeting at the end of each work cycle to share what the team accomplished and as well as what is coming next. Thank you for coming today. We'll try to keep the meeting both informative and concise. And whether you're joining us today for the first time or for many, many times, we appreciate your feedback on Surfliner. This, just a little bit of housekeeping, the meeting is being recorded, so please make sure that you mute yourself if you're not speaking. That'll help with the recording quality. And if you have any questions, feel free to enter them in the chat as you think of them. But in the interest of time, we will wait to answer questions until the end. So just so you know. The agenda for today is we're going to do a quick welcome and work cycle recap, and then we're going to move on to product updates. Then I'll come back and talk about the next work cycle and the priorities for that work cycle, and then we'll take any questions at the end. This is the work cycle overview for 2023 thus far. You can see that our winter and spring work cycle consisted of 4 work cycles. 2 of those were maintenance sprints. Those were the top priorities as identified in our prioritization meeting, and those sprints helped upgrade, and we'll talk a little bit about that in the product updates, but those were the 2 maintenance sprints, and then we had 2 LARC sprints, and that ended in on May 16th of 2023. The first 2 sprints were focused on maintenance and the second on LARC. We did not run a formal shoreline sprint, but we did have some shoreline work, integrating Comet and shoreline in the geospatial discovery. So you'll hear an update about that from the team today. I'm going to turn it over to Gabriella and Tamsin, who will share more about what was accomplished in Comet.
Thanks, Jessica. I'm going to be super brief here, but I want to start this segment with our opening credits for Comet and to acknowledge the individuals who have played and continue to play a role in the development of Comet, our digital object management platform. Many of these folks support other Surfliner products, and you'll see that as we cover the work that was done for Shoreline and LARC. Tamsin, care to tell us about Comet's goals for the spring work cycle?
I sure do. So as Gabriella mentioned, or sorry, as Jessica mentioned, some of the sprints that we ran during this work cycle were sort of split between Comet work and dependency updates. So in general, across all the Surfliner products, we did system and dependency updates. The main scope of that work was to do critical Ruby and Rails upgrades. The versions of Ruby and Rails that many of the products were running on were nearing end of life, so we really wanted to get that work done during this work cycle, and that was I think the highest priority for us. So that was a critical goal for Comet, and I'll say a bit more about that. And then the other goals that we had are really focused around the idea of making large-scale ingest ready to go. UCSB has imminent plans to ingest the ADRL content into Comet. We have other local other local collections that we're looking to ingest as soon as we have a clear mandate about what order we should be approaching those in. So we really wanted to make the large scale import and export behavior work. We had some configurable metadata improvements that we also felt were pretty high priority for being able to unblock that kind of ingest. So those got slated in here, and then we did include the idea of doing integration with the geospatial platform as part of this work. That was something that both campuses are interested in the short to medium term. So we wanted to move that forward, the geospatial integration also serves as a nice sort of ongoing developer test case for whether the batch ingest is working and whether the configurable metadata is working. So that was sort of a nice rubber duck for us. And then last but not least, we did have desire to make the Comet workflow a little more clear and to prepare some documentation and workshop content for that. And also I have a slide about that too. But let's do Comet dependency upgrades because this is a little bit substantial. So we did finish the Ruby and Rails upgrades that we had in mind for other products, but I won't say much more about those except to say, yay, that's tech debt repaid. I think we did a good job to prioritize that. That's a value of ours, is to not fall behind on those things. On the Comet side, we also got those Ruby and Rails upgrades done. In order to do that, we had to participate in some Samvera community work to facilitate a Hyrax 4.0 release, which added support to the Samvera dependencies that we have for Ruby 3 and Rails 6. So we got ourselves onto currently supported versions of Ruby and Rails that way. We also did some work to make the Bulkrax bulk import export engine, which we'll see in action shortly, compatible with that Hyrax 4.0 release. And then we did some work to fix various UI bugs that we encountered as a result of that upgrade. I think we were the first people to seriously move onto a Hyrax 4 release with its attendant Blacklight and Bootstrap. Bootstrap is sort of like the underlying design framework that we use across many of our products. And there was an upgrade to the version of that required some bug fixes to clean up the UI. So we took care of some of that as part of this sprint. In general, this has been a big success. It was a lot of work and it took a lot of attention, but we're really glad to be on the up-to-date versions of both the sort of core dependencies, the language, and the framework, and also for our Samvera community dependencies, which are an important. It's important to us to be up to date on those so that we're able to participate in that community in a meaningful way. Okay, let's do a demo. I have two things that I want to demo for us, and I'm going to apologize because I found that my screen share isn't working, so I'm going to ask Gabriella to take over screen share. And we did do quite a bit of different work, but we have a pretty short window to work with here. So the things I want to draw attention to are our work on the visibility models. Look, you can see I've been running batch ingests in the repository growth data there. But we'll demo the visibility and permissions behavior that we've worked on this sprint, or sorry, this work cycle. And then I want to do maybe a pretty limited batch object processing demo that I have queued up for you, Gabriella, and I'll walk you through kind of carefully. So first, can we go to the new object form? Let's click objects and add new object. Okay, and yeah, we can just pick one. So initially, what we had in place in this right side visibility menu was sort of just the default settings for Samvera projects. So it's possible to make an object public, as in it's visible to everyone, or it's possible to make it visible to only logged in users, or it's possible to set embargoes or leases that sort of change what the visibility is depending on the date. And then it's possible to make it private, as in only visible to people who have explicit permissions to read or access it. Prior to the work cycle, we had some sort of complex meetings about what the desired cross-campus most common permission settings were going to be. And we built out a model which you see almost complete here. I think we just need to remove the Surfliner button. Yeah. But I want to go ahead, first of all, Gabriella, and make a yeah, let's make a public object. Yeah, and you can name it anything you want, and if you don't mind attaching some file to it, so that we can see, because what I'm going to do is show us the metadata only behavior. And now I think there's sort of a known bug here. Yeah, where you have to go and like click and sample the title again to get the JavaScript to trigger. And then hit enter or something. There you go. Does that leave the file attached if you go back to the Files tab? No, it doesn't. Okay. Can you do me a favor and attach 2 files? This is a recent upstream bug that we're trying to squash down. But let's just work around it for now. Yeah, and then that should leave us a file attached. And then I want you to click public and save. Sorry, that's not the prettiest demo, but we did get a file attached. You can see at the top that this sample public object file is public, and also that down below that the file that's attached to it is also public. So the model that we implemented, if we go to edit, the model that we implemented includes some sort of basic group access. So the public group is everyone. The campus group is something that can be implemented campus by campus, but it might be like IP authentication or some other way of determining that a logged in or logged out user is on campus or has a campus affiliation in some way. And then there's Comet access, which means that anybody who's logged in to Comet, which should be restricted to library staff, are going to be granted access. And then there's private. Lastly, there's this kind of fun metadata only option, which I want to just exercise here. So let's go ahead and make this object metadata only and click save. Yeah, this form's great. Yes, please, we want to change this. Okay, so the behavior of metadata only is that now this object is public for the metadata. So that at the descriptive level of the object itself, you have visibility for everyone, but for the files that are attached to the object, the actual bit streams or whatever you want to call them, that those are accessed for Comet users only. So this was the most complex of the visibilities that we implemented, and I just wanted to show it off. But the real takeaway here in general is that we did sort of rework the whole model for how you sort of select what permissions exist for an object. This is important because the sort of vision here is that when I deposit an object to Comet, that I'm going to use the Comet interface to control where it's available and who it's available to. So this is the sort of who it's available to portion of that, which is global. Like if we see objects published to the geospatial platform or to a generic discovery platform, we'd expect these access rules to be applied in those platforms. Okay, so that's visibility. Real quickly, can we go back to the dashboard and go to importers? And I have queued up yeah, the interesting one is 000 stakeholder demo batch of 200. And I put this one in advance so that it would validate for us. But I want to go ahead and just click this import. So what we've done here is, well, maybe. Sorry, I think I was going to start, Gabriella, with just making a new import. And I want you to just maybe do that with whatever CSV file you have on hand. You're able to do that, right?
I don't know. Let me try.
Okay, well, let's at least look at this form. So if I want to start a batch import job for Comet, I need to provide a name for my import for the importer that I'm going to run. So let's name this one. Yeah, and just want to make sure we can find it. Import super duper, great. And then we're going to select a project, and the project controls some administrative information about the objects, most importantly, what workflow they go through. But we won't get into that too deeply. Let's go ahead and select a project. I don't really care which one. Sure. And then select the CSV parser, which is the only supported parser right now. And let's go as if we're going to upload a file. So at this point, I could upload. Yeah, if you have one that you know where it is, that's great. But otherwise, let's just end here. Oh yeah, batch imports, great. I don't care whether this succeeds or fails. I just want to show, let's do validate. Yeah, so this is what I've done with a large file that contains 200 objects. Gabriella's contains 3, and they just quickly validated for us. They say that they're valid. Gabriella, if you click on one of those source identifiers, so what has happened here is that we've parsed the CSV, made sure that the data is here. You can look here at either the original CSV rows that created this object if you click raw metadata. Or you can also look at the parsed metadata that's the metadata that's sort of queued up to create for this object. Cool. And let's go ahead and go back to the importer and just run it real quick and see what that looks like. Yeah, So if you click continue, then this importer will actually trigger, and then we need to like go back and browse to it, which is kind of frustrating. But yeah, you might just need to like page through. You called it super duper, right? So it's probably page 2, importer super duper. Yeah. Okay, cool. And did those actually create, or are they in the queue still? No, they're great. So that created some objects, the 3 that were in Gabriella's CSV. And then I want to go back to my CSV that contained 200 objects and just look at the metadata for 1 or 2 of those real quick, and then we can run that and talk about what it does when it runs. Okay, so this CSV is validated. There are 200 total objects in it. If we click on one of the source identifiers, you'll see that the objects in this importer have not yet created. The item link isn't here yet. Will you look at the parsed metadata for this? Cool. So so these objects are like mostly the same, except that I've given them like numbered titles. But importantly, what I want to call out here is that each of these objects has a couple of creators. So we're supporting multi-valued metadata fields. And then I've also attached files to them, to all 200 of them. And what I want to do now is go ahead and go back to the importer and run this. Yep. And then I want you to browse to manage staging.digital.library.edu/sidekiq, SIDEKIQ. And I think I hope you have access to this, Gabriella. Yes. So what's just happened? Yeah, click on enqueued. That's great. What's just happened when Gabriella pushed the import button is that those 200 objects got queued up to ingest, and what will happen with multiple ingests is that all the objects will just go into a background queue and get picked up by a worker. If you look at where it says busy near the top, this is a like a programmer facing interface, so I don't want to get too caught up on the interface here. But if you can see that in busy that there are 10 jobs running right now, this is sort of broadly scalable. So if the queues get very big, then it's possible to make the more workers process from the queue. And go ahead and click on busy. I want to just see real quick what's running. You can see there's some import jobs running. There's some file characterization jobs running. That means files are attaching. So lots of background things happen when we ingest objects. And what we'll see here is just all these 200 objects are going to get shoveled through the queue. They might be quite far along already if you go back to the queued. How many there? So okay, yeah. So about half of those have already run, and let's just let them go. And I want to go back to the importer and forget about this interface for a minute. So we can do the dashboard. And the importer, there we go. And let's just grab any of these objects. I just want to make sure that we can see that a file is attached. Yeah, so there's a PDF attached to this one. You can see the metadata got created. Some of the other ones have images attached. We should be getting characterization data for those attached files. And really the important thing that I want to call out here is that no matter how many ingests I'm running at a time, I'm just gonna put all of those files into this background queue and run them all concurrently with sort of stable batch processing tooling that we're borrowing from the Rails community. So you should expect in general to be able to ingest independently of whatever anybody else is doing in this system. Okay, so that's really what I wanted to show about what we actually implemented here. And can we go back to the slideshow? And I'll say, I think I'm pretty much out of time for a Comet update, so I'm going to be really fast about the next 2 slides. We did do rather a lot of work on the configurable metadata behavior. This was pretty far along before the work cycle, and we had named as a priority that we wanted to make it a little bit more robust during this work cycle. So we did some work to add controlled vocabulary support, which I'll come back to in the Lark update. And then to derive the search catalog configuration from the configurable metadata. So if you say that something should be searchable, then it is within Comet. And then lastly, to support better date formats with eDTF. That was one that we wanted to do for our ADRL ingest, besides other things. Is this an up-to-date slide deck? I have a filled-in slide here.
Sorry, this is the one that I have.
Okay, cute. In any case, we do have plans to do some work off-cycle. Like I mentioned, UCSB is planning a large-scale ingest into our production Comet instance. There you go. We'll do.
Sorry, there was just 2.
We'll do probably some expansion of the batch import functionality to support that, and really just whatever other work is needed to support that those incoming collections and QA of them. And then I didn't demo, but we did do quite a bit of work on the actual batch export part, which has a similar form and background processing behavior. The reason that, apart from time, the reason that I didn't demo it is that in our staging and production instances, there's a need to identify where we're going to export those large batches to for download. So right now they just sort of go to a place that then they're not going to be available from, and then the download link never becomes available and the files disappear. All the infrastructure works, like I can run it in dev, but we need an answer about where we're putting those files for where we're storing those files in the short term for download. And there's some infrastructure configuration to do to support whatever we decide on. So we'll probably do that work off work cycle. And then also we did begin the process of planning a Comet workflow workshop. We don't have a date for that yet, but I think we will continue to plan and move towards being able to give a user-facing, how does Comet workflow work? What kinds of things do you need to understand about moving objects through their life cycle in Comet? So expect to hear about that in the coming weeks. Okay, that's it for Comet. Sorry that I took so long. Can I hand it over to Amy and Alex?
You can. Thanks, Tamsin. Yeah, so we'll give a shoreline update. Next slide, please. So the main goal within this was really leveraging all of the work that Tamsin and Gabriella showed with what's happening within Comet. And so really looking at sort of the batch, sort of the end-to-end cycle of how do we take a CSV, how do we get it into Comet, and how do we get that pushed out to geodata. So that was the main goal. One of the big things that we got done right at the end was really aligning the M3 models, so the sort of configurable metadata models for both campuses. And why is this important? Is that both campuses have chosen to do and align a lot of their work pre-commit together. And so having each campus have separate metadata models, M3s, meant that we would have to sort of take a process earlier and divide our work there. So by aligning these models, and we were successfully able to deploy them and implement them without major changes, it's a huge thing. The light at the end of the tunnel grew drastically once we did this. So if we take a look, UCSB's is on the left, UCSD is on the right. And so just an example is UCSB had sort of the machine readable metadata creator, where UCSD had agent creator. And, you know, technically that's not that big of a deal, but for us that had an impact on our CSVs that we would ingest. And so next click, Jessica, please, or whoever, Gabriella. So you can see that while we have the base property of whatever each campus chooses, we created derived properties in the M3 that allow us and each campus sort of for the geospatial to be aligned. And so that means that we can have our CSV ingest be the same, but align with whatever campus has sort of at the base property. And so this was huge for us to support the previous work that we've been doing on getting that data ready to ingest into Comet and then be displayed in geodata. Next slide, please. So that was huge, but some of the other work that was happening behind the scenes, and we sort of take a look at that, is from the CSV to the Comet of sort of configuring what that language support will be within Comet. We know that geodata and the aardvark schema expect a certain criteria, and so we would like to be able to ingest that, so sort of standardizing that and stabilizing those CSV headers, which was that alignment of the M3s. Within Comet and Shoreline, we were able to look at and successfully passing sort of non-M3 fields, such as the title and the access rights that Tamsin just showed over. And so we can get those into geodata, taking a look at concatenating the bounding boxes, and having SuperSkunk produce an aardvark compatible JSON that can pass over. Alex, do you want to say anything else on that?
Yeah, so we can probably move to the next slide and I'll refer back if necessary. So yeah, the big push here was to kind of at least get the MVP, the minimum viable product, where, I mean, product might not be the right word here, but get the basic functionality in place where you can ingest a CSV file into Comet using the batch ingest functionality. And for a CSV that is of geospatial objects, Comet will then process it and pass it along to the Shoreline instance, where it can be displayed and accessed in a more appropriate way for geodata. And so I don't have a demo today because while right before I left for vacation, it seemed to be working. Then I get back, set up a test instance that's empty that I can use to show you, and everything breaks. So it goes. I could show you kind of our staging instance. It wouldn't really be very interesting to see because you would look on the Comet side and you would see, oh, there's a successful ingest. Go to the Shoreline side, you see some objects with like minimal metadata. But it's the kind of the magic of them, all the systems talking to each other, that is the interesting part. And yeah, that is the magic isn't happening this morning. But yeah, that it was a lot of work because we have not just 2 but 3 systems talking to each other to get this to work. So Comet receives the CSV, parses it, processes it, saves it. Then Comet actually sends out a message on our message queue saying, I have successfully ingested these objects. And so that's kind of like a little alert that other services can respond to. So Shoreline hears that and says, I want to ingest those. And so it doesn't actually query Comet directly. Amy mentioned SuperSkunk, which is our kind of access control service. And so that broadcast that Comet sends out says, if you want to know about these objects I've ingested, here is a URL for SuperSkunk. And so Shoreline queries that URL, asking SuperSkunk for the information and the metadata. If SuperSkunk deems that Shoreline can have access to this metadata, it then provides it in the format requested. In this case, the aardvark JSON. Shoreline receives that metadata and ingests it into its system. So that's the process. That is all more or less working. We're still getting all the metadata passed through. The bounding boxes we still have to translate. A couple other fields we need to map correctly, and the shapefiles themselves aren't being passed through yet. That's requiring a little bit of work because that's not part of the metadata, and so we need to add a new element to that broadcast that's sent out by Comet, including the actual file that can be ingested. So still work to do, but the basic functionality is there of each of these systems talking to each other and allowing each of these services to coordinate with each other.
And importantly, not everybody here may be aware, but this is a pattern that we're really hoping to reproduce for other front ends as well. So geodata is the first complex instance of this that we're trying to get working. So it's really nice to have it close.
So yeah, let's see, next slide. Oh, we're going backwards. Let's see. So yeah, here are a few more things that are kind of in progress but not yet complete. One of the reasons we haven't deployed this to production yet is kind of that Tamsin mentioned workflows earlier. In that bulk ingest interface, you could choose which workflow you want or which project you want to ingest into. A project is associated with workflow, which determines kind of what steps are involved in ingesting. So for our testing, for our minimum viable product, we set up a basic Shoreline workflow that as soon as you ingest geospatial data into Comet, sends it right along to Shoreline. That is probably not what we'll want to do in production. We'll probably want to have a mediated workflow where it's ingested, then is reviewed and approved. And once that approval process happens, then it's sent. So we have a bit of quality control. So I think Matt Critchlow has been working on that. It is, I think, just about ready, but we want to make sure that it's just right before we put everything into production. And then, Amy, do you want to talk about some of the other in progress steps?
Sure. So, and as we saw in Tamsin's demo earlier, right, sort of a file attachments, and one of these is being able to take files that are sort of outside of the staging environment and demo environment and really say, how do we attach files that are on each campus? And so that'll be a unique sort of scenario likely for each campus to get those files into Comet. And so that's one of the big things that we're still working on. And then ultimately making the original file set available to end users via a public endpoint. And that means that we are providing Comet with 2 files. One of those is a derivative that's used for display purposes only on the map. The other is the original one that we want to provide to end users. But those end users need to be able to have access from a public endpoint. And so how does that work because Comet is not necessarily supposed to be that public endpoint. And so it's just figuring out how that all works together. So those are the details in all of this, but it's so exciting to be at these details rather than still this high level. And then one of the other things that we're still working through is collections. And so in geodata and shoreline, we'd like to organize our data sets by collections. And so how do we get that collection information sort of captured in Comet and also passed over to shoreline? And some of the changes that have been made on the geo blacklight shoreline side that align with what's going in with Comet. So just working through some of these final details, but it is exciting to be at this point. So those are some of the things that we're working on and that are helping to finalize that end-to-end workflow with Comet and Super Skunk and all of the other products, Lark and Shoreline. So I think that's it. Tamsin, back over to you.
Yeah, I'm gonna fly through the Lark update because I'd like to leave time for questions. So Lark is the authority control platform. The vision for Lark is for a cross-campus way of creating and managing controlled terms using the simple knowledge organization system, and then for us to have tooling for reconciliation, et cetera. Work on Lark had been on hold for some time, but we're very interested in being able to do integration with Comet. So we re-upped work, and our goal was really, again, to bring the dependencies up to date, to support some basic MVP functionality, and then to do demoable integration with Comet. Can we do the next slide? So we did do a bunch of these things. Importantly, on the MVP front, we added support for the SCOS extension for labels, which allows us to do things like have campus-specific or usage notes on labels in particular, which would make it possible for us to share terminology even when we have different display labels that we'd like to show for them, and also to track what the source of those labels is. And then we did do a bunch of work, mostly on the Comet side, to support integration with Lark, but we didn't get to a demoable version of this. We had two versions of that we were interested in kicking around. One is to be able to support constraint validation on that batch ingest process we saw before. And then the other is to do lookup from the new and edit object form. So if I am typing in a field, I get options for what allowable labels I would have. Neither of those quite got done, but we're interested in continuing work on them. I think we may actually do part of this batch ingest work in the coming off cycle. So that's it for Lark. I'll stop there and let Jessica do upcoming.
I'm going to quickly do upcoming work. We have some upcoming sprint cycles in the fall. Those sprint cycles, there are 4 of them. They start in early September and then end at the end of November. We do have a break in there for Samvera Connect, which is the open source software that we use to write the system at the end of October. But those 4 sprints have not quite been defined yet, but we will go back to our priorities. I'm going to reference the prioritization exercise that is in the blog if anybody wants to see this at a more detailed level. So our first objective will be to finish the higher priority work that we determined during this exercise. That's finishing the significant work towards the integration of Comet and Lark, and then plan for the future discovery layers. That product will be called Daylight. And then we'll move on to the lower priority work that is a lot more of the Shoreline, Orange Empire, IIIF work, and then some of the Starlight work, including trying to integrate Starlight and Comet so that Starlight can read collections and objects in Comet. If you want to know how to stay up to date, these are our Slack channels. We have the Slack channel, which is just the Surfliner channel. That is all of Surfliner. And then if you're interested in something that isn't quite daily updates on what's going on with the team, you can always join Surfliner Announce. That channel is just the announcements for Surfliner. And then obviously our blog, surfliner.ucsd.edu, or you can always reach out to Chrissy or myself, and we will happily either put you in touch with a product owner or try to fill you in ourselves. And at this point, and we have a little bit of time to, if anybody has any questions. There is no questions in the chat, but I'm gonna stop sharing and see if anybody wants to ask a question.
While we wait for questions, I just want to say that the team did really fantastic work this work cycle. What we've just been over is a pretty quick slice of what all happened during this
Tamsin,
period.
as you were going through it, I was like, if they wouldn't have been so productive, we could have gotten this all shoved in the time that we
I
allowed.
know, right?
So yes, everyone was super productive. Very exciting work that happened this work cycle.
Tamsin, I have a quick question. Sorry.
No, go for it, Amy.
And I think it was when you were demonstrating, you had the bulk ingest of the 200 files, and you had sort of preloaded that. And I think in the bottom, there's I think create and validate and create and import. By creating and validating, I think, does that sort of prep everything in sort of that, like I don't know what you call it, like a staging environment, because you were able to go back to that. And so I'm thinking, I guess I'm just curious, because that put all of those in queue or sort of waiting to be imported. Is that how that's the best way to read that?
Yeah, you're understanding right. So the validate step happens regardless of which of these you click. Pushing validate allows you that time to sort of like see what these objects look like before the actual ingest tries to run. I think it's really the best way to approach this. You can also just click create and then manually validate as a future step. There's a lot of options here, but yeah, what's happening then is that the metadata gets parsed and checked against programmatic validations, which might include things like, I think right now it just includes like, does this title exist? But it may include also things like, are we conforming to the controlled vocabularies that we've specified? And then that parsed data gets stored temporarily, but not in the Comet metadata store. It just gets stored in a database somewhere, so that when I run the ingest, I have that parsed information and can access it. So that's sort of what's happening there, is that all of these objects are getting loaded off into infrastructure that's just there to handle the bulk processing. And then you can run the ingest at a later time. And you can, the like common, I think at UCSD, you call it overlay functionality, works here. So if I have objects and I run imports with objects that have the same IDs or the same bulk process specific ID, then I can do updates that way. I think we've demoed that in past work cycle, in past sprint updates, but it wasn't practical to try to do an update demo in this context. I just wanted to show you how neat it was that it all runs in parallel.
Thank you.
Thanks for getting the question ball rolling, Amy. I appreciate that. Anything else? All right. Well, if there are no other questions, Gabriella, I think we can stop the recording. And then